Welcome everyone. In this problem we have a biconvex lens with radius of curvature 20 cm for both surfaces. The refractive index is 1.5 and one surface of the lens is silvered. An object is placed at a distance x centimeters from the lens. We need to find the value of x such that the image is formed on the object itself. There are three key concepts to understand here. First, when one surface of a lens is silvered, the whole system behaves as an equivalent mirror, not just a lens. Second, the power of this equivalent mirror equals 2 times the power of the lens plus the power of the mirror surface. Light travels through the lens twice because it refracts in, reflects off the silvered surface, and refracts out. Third, for the image to form exactly on the object must be placed at the center of curvature of this equivalent mirror, which means the object distance equals 2 times the focal length of the equivalent mirror. Now let us solve the problem step by step. Step 1. Find the focal length of the lens. Using the Lensmaker equation, 1 over FL equals mu minus 1 times 1 over R1 plus 1 over R2. Since it is biconvex, both surfaces curve toward the center, so we add the terms. Substituting values, we get 1 over FL equals 0.5 times 2 over 20, which gives FL equals 20 centimeters. The power of the lens PL is 1 over 20. Step 2. The silvered surface acts as a concave mirror. Its focal length FM equals R over 2 equals 20 over 2 equals 10 centimeters. So PM equals 1 over 10. Step 3. The equivalent power is PEQ equals 2 times PL plus PM, because light passes through the lens twice. This gives 2 times 1 over 20 plus 1 over 10, which equals 1 over 10 plus 1 over 10, which equals 2 over 10, which equals 1 over 5. So the equivalent focal length FEQ equals 5 centimeters. Step 4. For the image to form on the object itself, the object must be placed at the center of curvature of this equivalent mirror. That means x equals 2 times FEQ equals 2 times 5 equals 10 centimeters. The answer is x equals 10 centimeters.